Today's lesson is on similar polygons. Take a minute to read over the learning goal and scale. Find where you are on the scale before we begin the lesson. Similar figures have the same shape but not necessarily the same size. We use this symbol for is similar to. We can use ratios and proportions to decide whether two polygons are similar and to find unknown side lengths of similar figures. Two polygons are similar polygons if corresponding angles are congruent and if the lengths of the corresponding sides are proportional. Notice that angle A is congruent to angle G, angle B is congruent to angle H, angle C is congruent to angle I, and angle D is congruent to angle J. In order for sides of polygons to be proportional, the corresponding sides, such as side AB and side GH, must have an equivalent ratio to sides BC and side HI, side CD to side IJ, and side DA to side JG. When we write a similarity statement, we write corresponding vertices in order, just as we write congruent statements. When three or more ratios are equal, we can write an extended proportion, such as this one here. A scale factor is a ratio of corresponding linear measurements of two similar figures. The ratio of the lengths of the corresponding sides, side BC and side YZ, is the length of side BC to YZ equals 20 to 8, which reduces to 5 to 2. So the scale factor of triangle ABC to triangle XYZ is 5 to 2, or written with a colon 5 to 2. In example 1, we will understand similarity. Triangle MNP is similar to triangle SRT. What are the pairs of congruent angles? Remember that in similar polygons, all corresponding angles are congruent. So let's take a look at each angle. Here, angle M is the first angle in the name. Angle S is the first angle in the name of the second triangle. So we know that angle M is congruent to angle S. Since N is the second letter in the first triangle and R is the second letter in the second triangle, we know that angle N is congruent to angle R. And finally, since P and T are the last letters in each name of the triangles, we know that angle P is congruent to angle T. For part B, what is the extended proportion for the ratios of the lengths of the corresponding sides? The first two letters in the names of our triangles, side MN and side SR, will be our first ratio. The second two letters, NP and RT, will be our second ratio. And the first and last letter of each triangle name will be our third ratio, so MP and ST. So the ratio of the length of segment MN to segment SR is equal to the length of segment NP and segment RT, which is also equal to the length of segments MP and ST. Now pause the video and do you try number 1. We're going to use the fact that polygon DEFG is similar to polygon HJKL. To answer part A, what are the pairs of congruent angles? Again, use the name. The first letters, D and H, represent the first pair of congruent angles. The second letters, E and J, represent the second pair of congruent angles. The third letters, F and K, represent the third pair of congruent angles. And the fourth pair of letters, G and L, represent the fourth pair of congruent angles. For part B, we will write the extended proportion for the ratios of the lengths of the corresponding sides. So side DE to side HJ, side EF and side JK are our second ratio. Sides FG and KL are our third ratio. And sides DG and HL are our fourth ratio. Notice that the sides of the first polygon are all on top and the sides of the second polygon are all on bottom. In example 2, we will determine similarity. Are the polygons similar? If they are, write a similarity statement and give the scale factor. Let's begin by identifying the pairs of congruent angles. Since angle J is congruent to angle T, angle K is congruent to angle U, angle L is congruent to angle V, and angle M is congruent to angle W. All the corresponding angles are congruent. Now let's compare the ratios of the corresponding sides. Let's start with side JK to side TU, which will give us a ratio of 12:6, which is 2:1 when simplified. Now let's look at side KL to side UV for a ratio of 24:16, which is 3:2 when simplified. Next, let's look at the ratio of side LM to side VW for a ratio of 24:14, which is 12:7 when simplified. And finally, we will write the ratio of side MJ to side WT, which is 6:6, or 1:1 when simplified. Since the ratios of the lengths of the sides are not proportional, the two polygons are not similar. For part B, let's start again by identifying the congruent pairs of angles. Notice that angle C is congruent to angle F, angle A is congruent to angle D, and angle B is congruent to angle E. Since all three pairs of corresponding angles are congruent, let's move on and compare the ratios of the corresponding sides. Let's start with the shortest side, side CA and side FD. That will give us a ratio of 8:10, which simplified is 4:5. Our second ratio will go with the medium length side, side AB to side DE, for a ratio of 12:15. When simplified, this ratio is also 4:5. Now let's look at the ratio of the longest sides, side BC and side EF. This will give us a ratio of 16:20. When simplified, this ratio is also 4:5. Since all three pairs of corresponding angles are congruent and all three corresponding side pairs are proportional, we have similar triangles. So we're going to write our similarity statement. Remember, they must be in corresponding order. So we will write triangle CAB is similar to triangle FDE. The scale factor will be the simplified ratio of the side lengths. So our scale factor is 4:5. Pause the video and do you try number 2. Are the polygons similar? If they are, write a similarity statement and give the scale factor. Let's start by identifying the congruent angle pairs. Angle K is congruent to angle X. Angle L is congruent to angle Y. Angle M is congruent to angle Z. And angle N is congruent to angle W. Now let's compare the ratios of the corresponding sides. We'll start with the shorter sides of each rectangle, side KL and side XY. This will give us the ratio of 10:15, which when simplified is 2:3. Now let's look at the ratio of the longer sides, side KN and side XW. This will give us the ratio of 15:20, which when simplified is 3:4. Even though all of the corresponding angles are congruent, because the corresponding sides are not proportional, our two rectangles are not similar. For part B, let's start by identifying the pairs of congruent angles. Angle A is congruent to angle S. Angle B is congruent to angle R. Angle C is congruent to angle V. Angle D is congruent to angle U. And angle E is congruent to angle T. Now let's compare the ratios of corresponding sides. Let's start with side AB to side SR. This will give us the ratio of 18:9, which when simplified is 2:1. Since side BC and CD are also 18, and side RV and VU are also 9, those ratios will be 2 to 1 as well. Side DE to side UT give us the ratio of 12 to 6, which simplifies to 2 to 1. Since the lengths of side EA and side TS are also 12 and 6, they will give us the ratio of 2 to 1 as well. Since all corresponding angles are congruent and all corresponding sides are proportional, the polygons are similar. Let's use our angles, our congruent statement for our angles, to help us write the names of the polygon in corresponding order. So polygon ABCDE is similar to polygon SRVUT. And the scale factor is 2 to 1. In example 3, we will use similar polygons. Polygon ABCD is similar to polygon EFGD. What is the value of x? Since corresponding sides of similar polygons are proportional, we can write the ratio, the length of side DE to side DA is equal to the length of side FG to BC. We'll now substitute with the corresponding lengths, so we will get the ratio 6 to 9 is equal to x to 7.5. Using cross product properties, we will get 45 equals 9x. Divide both sides by 9, and x equals 5. Because the video is running long, I'm going to leave it up to you to check to make sure your answer is correct. Go ahead and pause the video and do you try number 3. Find the value of y. Using the same first ratio, side DE to side DA, or 6 to 9, we will now set it equal to side EF to AB. Using cross product properties, we will get 30 equal to 9y. Divide both sides by 9, and y will equal 10 to 3, 10 over 3, or 3.3. In example 4, we will use similarity. Your class is making a rectangular poster for a rally. The poster's design is 6 inches high by 10 inches wide. The space allowed for the poster is 4 feet high by 8 feet wide. What are the dimensions of the largest complete poster that will fit in the space? Since we don't have units that are the same, let's convert our feet into inches. Now let's see how many times bigger we can make our design by dividing the space where our poster can fit by the size of our design. At most, we can enlarge our poster 8 times. If we enlarged it 9.6 times, it would be too big to fit in our 48-inch height restriction. Now we'll write a proportion using this ratio and our design's width to find the width of our large poster. Using cross products property, we will get 480 equals 6x, divide both sides by 6, and x equals 80. So the largest complete poster that will fit in our space is 48 inches by 80 inches, or 4 feet by 6 2/3 feet, which converts to 6 feet 8 inches. Pause the video and do you try number 4. Here, your class is using the same design, but needs to know the dimensions of the largest complete poster that will fit in a space that is 3 feet high by 4 feet wide. Start by converting your feet to inches. Now find the possible enlargement by dividing the space available by the corresponding height or width. Since the greatest enlargement is 4.8 times larger, we will use this ratio in our proportion. Using cross products property, we will get 288 equals 10x, divide both sides by 10, and x equals 28.8. So the largest poster that will fit in our available space is 28.8 inches by 48 inches.